So, solution stoichiometry. So we already kind of talked about how molarity can be used to convert between amounts. If I had moles and I was trying to find volume, or if I had volume and I had moles. So the stoichiometry part is, remember we could talk about going from one compound to another compound. That is going from moles of one to moles of another. So remember, if I want to switch the compound, it has to be in moles, and this is the ratio of my coefficients. And that comes from a balanced equation. So to get from moles of one thing to moles of another, this is stoichiometry. I get the ratio from the coefficients from my balanced equation, and I could go from one to the other. So before, when we did stoichiometry, I would usually have grams here. I'd have grams, and I'd have to put it in moles, and I would use the molar mass. But this chapter, we're talking about solutions. So this is solution stoichiometry. Here's the stoichiometry part, but we're starting with the solution. So if I have so much of a solution, to be able to go to another solution, I have to first be able to put it in moles, so then I could switch my substance. So if I have volume, and I need to get to moles, I need something that relates volume and moles. And that's where the molarity comes into play. So to go from volume to moles, or from moles to volume, I would use the molarity as the conversion. So I'm going to have the volume of one, use my molarity to get to the right units of that one. Then I could go from one to the other, and then go use the molarity to get to the volume. All right, so this is kind of just the vision of what we would do. So now let's look at a problem. One volume of 0.150 molar KCl is required to completely react with 0.15 liters of 0.175 molar PbNO3 in the reaction. So I give you the balanced equation, and so we want to know what? What are we looking for? We're looking for the volume of this guy. So I find that guy, and underneath it, I just say volume. And I'm going to let you know that I want it in liters. So I want the volume of that guy. Okay? So what did they give me? They gave me the molarity of that guy. What else did they give me? They gave me the volume of this guy. And they gave me the molarity of that guy. All right, so now I can kind of visually see what I have. So I want the volume of this guy. So let's think about this. So if I want the volume of this guy, all I have is the molarity. So molarity, remember, molarity is moles over liters. So the molarity has the liters in it. But if I want the volume, and I have the molarity, that means I also have to have the moles. But I don't have the moles of this, do I? They didn't give it to me. So that means that I have to use these somehow. So to be able to find the volume using the molarity, I need to know the moles of this guy. Okay, well I don't. But could I find the moles of this guy by knowing this guy? How do the moles of this guy relate to this guy? With that balanced equation, right? So the moles of this guy and this guy relate based on my balanced equation. But do I have the moles of this guy? Well, here I've got the molarity, I've got the liters, so I could find the moles of this guy and then relate it to that, which is exactly what we kind of just did here. I said I needed the volume, and I kind of taught myself backwards. Okay? So what we need to do is we need to start with this guy. Or if you're really confused, you have nowhere to start, and have no idea where to start, always remember start with the simplest thing. So what's the simplest thing? Well, that has units in it, that has units in it, that's one unit. So when in doubt, start with the simplest. So I have 0.150 liters of PbNO3. So I have the volume. I need to get here. The only way I could go from here to here is through the mole, because you can only go from one thing to something different in the mole. So I have liters, but I want moles. So say, okay, I have liters of this guy, but I really want moles of this guy. So if I have liters and I want moles, I need something that relates moles and liters. Well, what relates a mole and a liter? The molarity. So where does this number gonna go? So remember, I could rewrite this as 0.175 moles in 1 liter. So that number is gonna go with my moles and 1 here. And make sure you pick the molarity that goes with the right guy. That's why I write my units here. So now I have moles of this guy. So now I have moles of him. So now that he's in a mole, I can actually switch the guy. I could go from him to him because he's in the right units. So now I could go from moles of this guy to moles of the guy I was looking for. And how do I do that? How do I go from moles of one thing to moles of the other? My balanced equation. So what's the relationship? 2 moles of KCl for 1 mole of PbNO3, 2. So the 2 is going to go here with the KCl, and my 1 goes on the bottom. So now I have moles of KCl. So now I'm on this side, and I have moles. But I don't want moles. What do I want? I want volume. So what relates my moles? If I have moles, I want volume, I have to use the molarity, just like I used here. So moles of my KCl is going to go on the bottom. Liters of my KCl is going to go on top. Okay? What has moles and liters? Molarity. So what is the molarity of my KCl? 0.15. The 0.15 goes with the moles. So 0.15 goes on the bottom. And the 1 goes on top. So now I have the liters of my KCl. So then you do the math, this times this times this, divided by that. And it will give you 0.350 liters of KCl. And the way you can kind of think about if this makes sense, these two numbers are pretty close together. And so this number and this number should be pretty close together as well, okay? Because it's not going to be like a whole, like you shouldn't have 0.1 and then like 35 or something like that. Should be like in the same magnitude of the two numbers. All right, so if you notice here, all I did is I used my molarity to get to my stoichiometry, and then I used my molarity again, which is what we said we would do here. We'd use the molarity to get to my stoichiometry to use my molarity again, okay? And so the big thing with this is that I can only go from one thing to something different in that mole-to-mole relationship, but I'm starting with volume, so I have to use molarity to get me to that and not the molar mass or something of that nature. All right, so if you're completely tired with all this math at the beginning of this chapter, I get it. But remember, this chapter, we have a lot of different things we're covering in this chapter. So chapter 8 is just got a bunch of different little topics that we're talking about. So this whole section was on concentration and then different ways that we can use molarity to find molarity, to use molarity as a conversion, and to use molarity in dilution or solution stoichiometry. So now we're going to switch to kind of more theoretical topics and talk about a few definitions.